Okay, we're back. This is part 2. I've done the first 60 in the other video. So we're picking up with 61. At STP, which element is solid, brittle, and a poor conductor of electricity? So this is a non-metal, but we want, I don't like that green, but we want a solid, so that would be sulfur. Metal, metal, non-metal gas. Stable electron configuration, this is noble gas. This is group 18 on the periodic table, so that would be neon. Which explains why neon is a noble, I think I just said it, is a group 18, stable valence electron configuration. Just because it's a gas doesn't make it group 18. Low melting point doesn't make it in there, and 2 electrons in the first shell. Which group 14 element is a metalloid? So that starts with carbon. Carbon is a non-metal. And then silicon is a metalloid. So that's probably our answer. Both metallic and non-metallic properties would be a metalloid. So there we go. Liquid at STP, you got to know these. We've got bromine and we've got mercury. Malleable, metal. Good conductor. We got metals. Metals, metals. So this is a non-metal. This is a non-metal. This is a non-metal. This is a metal, silver. Aqueous solutions of compound containing element X are blue. So we want a transition metal. Oh, that's a terrible periodic table. But this center here is called the transitions, and that's where you want your colorful solutions. Copper lives in there. Copper is number 29. What's the total number of electrons in an Al plus 3? So aluminum normally has 13. But the fact that it says plus 3 means we've lost 3. So it has 10. Sorry for my cough. What is the net? Net means overall. What is the overall charge in an ion that has, okay, well, first of all, those have no charge. 8 protons and 10 electrons. Electrons are negative. So overall, we're negative 2. When an atom of lithium loses electrons, when you lose weight, what happens to your radius? You get smaller. And when you lose electrons, you become positive. You like losing weight? Positive. It's not a very body positive example, so I'm just going to say losing electrons, you become positive. As elements in period 3 are considered in increasing atomic order, what atomic number? What is there a decrease in? So probably have to look at table S. Atomic mass does not decrease. Atomic radius, maybe. I'm going to tell you yes. If you look at table S, look across, atomic radius goes down as you go. So which characteristics decrease when you're going across period 3? Decreasing non-metallic properties? No, we're becoming more like nonmetals. So metallic properties decrease, atomic radius decreases. Go ahead and look it up. Table S. When an atom of phosphorus becomes phosphide, that means a gain of 3 electrons, negative 3, which means our radius is going to increase. We're going to get bigger to accommodate those extra electrons. Which general trends in ionization energy and electronegativities are demonstrated by group 15 elements as they're going from top to bottom? So look it up. Just go to the reference table. I will tell you that because they increase across a group, they're going to decrease going down a group. But don't take my word for it. Go to table S and just look it up. Go down. Which cannot be broken down by a chemical change? So elements. So any elements. These have meth probe C3. I can't even do it off the top of my head, but it doesn't matter. Sorry, don't judge me. You're looking for elements. Which change is most likely to occur when H2 and I2 collide? Well, if they're colliding, that's going to be a chemical change, and we're going to form a compound. 77 is A. Lead 4 oxide. That means lead is a plus 4. Oxide's a minus 2. That does not equal out. So if you crisscross, you get Pb2O4. That can be simplified to PbO2. Choice A. Strontium phosphate. So strontium is Sr, And strontium has a charge of +2. And phosphate is PO4 -3. So we crisscross them, you get SR3, PO4 in parentheses taken twice. That's choice D. Iron Roman numeral 3 oxide means iron +3. O is -2, so crisscross them, you get Fe2O3B. So first let's write it. Ca +2, Br -1, Ca +2, O -2, Ca +2, P -3, so, and Ca +2, S -2. So who is in a 1-to-2 ratio? That's going to be 1. Okay, we got to name this thing. First of all, 10H2O is called a decahydrate. So that takes care of those. So Na is sodium and carbonate. Disodium. No. It's just a sodium carbonate. When a compound ends with IDE, it is a binary compound. The name corresponding to Na2SO3 is sodium SO3. I'm flipping to table E. That is sulfite. Sodium sulfite. Okay, this is on table E again. That's permanganate. Total number of atoms in that thing, and again, I'm sorry about the spacing, but let's see. We have 2 plus 1 plus 3 plus 20 plus another 10. So 36. You gotta count everything. Which equation is balanced? Meaning you have to count all the atoms on both sides, make sure they are equal. So 2K is 1K. No, that's not. 1 Na, 1 Na. 2 H's, 3 H's. Nope. 1 Ca, 1 Ca. 4 H's, 4 H's. 2 O's, 2 O's. This is probably it. 1 zinc, 1 zinc. Okay, that's not it. And then that's not it. Yeah. Balance it. So let's see. AlOH3 plus HCl yields AlCl3 plus H2O. So Al1O is 3, H is 4, Cl is 1. Al1O is 1, H is 2, Cl is 3. So, again, I don't know if this is going to work right off the top, but chlorine's 3. 3 and 3 is 6. 3. 3. 6. 3. That'll do it. So, coefficient of HCl is a 3. And balancing a chemical equation, what makes it's conservation of mass, law of conservation. Again, correctly balanced, we'll have the same number of atoms on both sides. No, and no, and yes, and no. The formula and it's done. The formula mass, gram formula mass, is the sum of the atomic mass of its atoms. What is the GFM of that? So, periodic table, iron, and we're going to round these, 56. Now, this is distributed. So, nitrogen is 14, but there are 3 of them. So, that's 42. And oxygen is 16, but there are 9 of them. So, adding them up, you get 242 grams per mole. What is the GFM of that? Okay, so calcium is 40, but there are 3 of them. Phosphorus is 31, but there are 2 of them. Oxygen is 16, but there are 8 of them. And then you add them up. 310. Empirical formula is CH3, so molecular is any 1 to 3 ratio. That's a 1 to 4 ratio. That's a 1 to 2 ratio. This is a 2 to 3 ratio. I'm sorry, a 1 to 3 ratio when you divide it down. This is a 1 to 2 ratio. Giving me some space here. Percent composition. Massive part over massive whole times 100. So chlorine has a mass of 35, and it's given you the 4 choices. So 35 over 52 times 100. 35 over 68 times 100. 35 over 84 times 100. And 100 over, whoops, that's wrong. 35 over 100. Times 100. It's not that one. That's 35%. So less than half. 35 over 52 times 100. Well, that's more than half. 35 over 84. That's 42%. Yeah, it's choice C. What is the percent composition of nitrogen? So there are 2 of them, so that's 14 times 2 is 28. Gave you the whole thing, though. That's nice. Times 100. 28 divided by 96 times 100 is 29.1. 1/6, which rounds to that. Smallest percent composition by mass of chlorine. So 35 is chlorine. HCl is, that's 35 plus 1 is 36 times 100, of course. K is 39 plus 35, so that's 74. Lithium is 7 plus 35, so that's 42. And Na is 23 plus 35. So, and all these would be percentages. So, which is going to be the smallest percent? 35 over 74? 47%? I'm going with KCl. Yeah. What kind of reaction is this? Well, we got, looks like a switcheroo. F is replacing I. That's called a single replacement. You have to make sure it even works. Table J. What kind of reaction is this? Looks like a double replacement, because we've got K switching with Ba. And so do-si-do your partners. 3 kinds of chemical reaction: decomposition, single replacement, and solidification. Decomposition, single replacement, double replacement. Bingo. Which type of reaction? Looks like we're coming together to form one. That's a synthesis. What are all these things? They are conserved. Formula of the missing product. 2 ways you can do this. 1, you can count up all your atoms and make sure you follow the law of conservation, or you can say hydrocarbon plus oxygen yields CO2 and H2O. That is the formula of a, this is a combustion reaction. Okay, stoichiometry. First of all, we got a balanced reaction. I have 2 moles NH3, so that is what I know. And I seek water. So mole to mole stoichiometry, you just seek over no, so this is a 6 over 4. So 2 times 6 is 12, divided by 4 is 3. What is the mole ratio of NaOH to AlOH3? So 6 to 2. That's not there, but 1 to 3 is there, which is a 3 to 1. Sorry. Which sample contains a total of 6.02 times 10 to the 23rd atoms? This is 1 mole. So 1 mole is equal to Avogadro's number, 22.4 liters, and also the GFM. So it's looking to see which one of those is lined up with their proper GFM, which is A, sodium. The mass of sodium is 23. Carbon's mass is 12. So that's not it. Krypton's is 84. At STP, 1 liter of helium contains the same number of atoms as a liter of neon. And the reason why is, this is Avogadro's hypothesis, which states any gases at the same conditions of temperature, pressure, and volume will have the same number of particles. What occurs as bonds are broken? So energy has to be absorbed because it is on the reactant side. And 2 moles of unbonded hydrogen atoms are produced. 1 mole of hydrogen atoms are produced. Well, I see 2, so I'm going to go with 2. Which diatomic molecule is formed when there are sharing 6 electrons? Oh, no. I don't think you could answer this one yet. Yeah, this is nitrogen. Didn't teach that one yet. Oops. Which symbol represents an atom with a ground state with the most stable valence electrons? This would be, yeah, careful. This is D, neon. Lowest electronegativity value, F is the highest. Just take a look on table S, but I believe it is francium. Greatest tendency to attract electrons, that's greatest electronegativity. I'm going to go with chlorine, but don't take my word for it. It is. It's on table S. So how strongly you're attracting electrons, it's called electronegativity, based on electronegativity values, which has the greatest attraction for electrons to bond. So the greatest electronegativities are the nonmetals, so they have the greatest attraction for electrons. Gold can be flattened into thin sheets. Why? Because of the nature of the bonds. I'm going to go with that. Crystal structure. Crystalline is a solid. What is formed when 2 atoms of bromine bond together? That would be a diatomic molecule. Which element is a yellow solid? This is just something we need to know. This is sulfur. Which is not a safe lab procedure? Not safe. Goggles are safe. Wafting is safe. The chemicals down the drain could be bad. Cleaning is safe. A sign says never drink from the glassware. Why? Because many chemicals are poisonous. That's it. Chemicals are reused. No. It could spread germs. Yes, but that's not why. Yeah, it's that one. So it appears that number 109 slipped in there and they shouldn't have. So you can avoid that one, but everything else should be good. If you have any questions, please reach out. Thank you.